I'm Andreas Hamberger, and this is the Hamberger Report, where I cover AI governance, enterprise architecture, and the technology decisions that actually matter to the people who have to make them. If you find this useful, subscribe and hit the like button. It helps more professionals find the channel. Now let's get into it. On the 28th of February 2026, Donald Knuth published a 5-page paper. It opens with 2 words: shock, shock. Knuth is 87 years old. He wrote The Art of Computer Programming. He has spent a career on problems that resist solution. One such problem had been on his desk for weeks. Can the edges of a directed graph with m-cubed vertices be partitioned into exactly 3 Hamiltonian cycles? He gave the problem to Claude Opus 4.6. In approximately 1 hour, across 31 systematic explorations, Claude tried brute force approaches, invented construction patterns, hit dead ends, changed strategy, and found a solution that worked for all odd-numbered cases. His colleague tested it computationally for every odd-numbered up to 101. Correct every time. Then Claude could not prove it was correct. Knuth wrote the mathematical proof himself. He found that Claude's construction was one of exactly 760 valid decompositions, corresponding to a known structure called the modular Emery-Gray code, which Claude had rediscovered from scratch without knowing what it was rediscovering. 5 days later, on the 5th of March, a Japanese private rocket designated Kairos 3 lifted from spaceport Kai in Wakayama Prefecture. Its autonomous flight safety system terminated the vehicle at approximately 69 seconds into flight. Preliminary investigation found no significant abnormalities in the rocket's trajectory. Experts examining the data still cannot agree whether the system was right. 2 events, 1 week, the same structural problem. AI systems can now reason at expert level. They cannot verify their own reasoning. That gap has a name. I'm Andreas Hamberger. This is the Hamberger Report, where I cover building an AI hallucination detection engine from concept to commercial product. The verification gap is the distance between an AI system's ability to generate conclusions and its ability to confirm those conclusions are correct. It is not a bug. It is a structural feature of systems that produce outputs through pattern recognition and probabilistic generation, rather than by maintaining formal proof chains. Today we cover phases D and E of the TOGAF architecture development method, the technology engine V.E.R.A has built, and the commercial opportunity the verification gap creates. V.E.R.A, as response to the verification gap, is architectural, 6 layers, each running as an isolated Docker container, each with its own failure boundary. A crash in the PII scanner does not take down the Crampits analyzer. The layers fail independently because they were designed to. The performance story is counterintuitive. V.E.R.A adds verification overhead to every query. That overhead must be fast enough to justify itself. The numbers steps 1 through 6, the entire NTP verification pipeline, target a combined latency of under 170 milliseconds. The Claude API call takes up to 3000 milliseconds. S verification overhead is roughly 5% of the total response time. This dismantles the most common objection to verification systems: won't it make everything slow? The Crampits analyzer runs in under 10 milliseconds. It applies 9 rules to a formula and returns a result. No model inference, no network call. Mathematics is fast. The observability stack includes 5 monitoring dashboards. The most important is the Hallucination Index. It tracks the rate at which the output validator catches entity claims the LLM introduced despite NTP constraints in the prompt. A rising index means the system is drifting. The response is prompt refinement, model update, or in extreme cases a circuit breaker that pauses the service. One security property deserves special emphasis. The NTP logic in Layer 3 is deterministic. It is not a machine learning model that can be adversarially attacked or jailbroken. The Crampits rules are mathematical, R1 through R9, validated from Vessel 1992, implemented as conditional logic in Python. You cannot prompt inject your way past a mathematical proof. V.E.R.A. V.E.R.A. applied to the Knuth case. The Crumpets analyzer would classify each of Claude's 31 construction attempts as an E-type claim, flagging each for existence verification before assertion. The EAT verification service would block the I found it claim until computationally confirmed. The D service would detect that Claude's serpentine pattern and the classical modular Emery-Gray code are the same mathematical object under different names, preventing a false novelty claim. Phase E of the TOGAF ADM asks a pointed question. Given the architecture, where does it create the most value earliest for V.E.R.A? The answer is clear. The verification gap is not a theoretical concern. It is an active commercial problem across every regulated sector where AI is being deployed. 5 sectors, each with a different cost of error. In pharmaceutical contexts, a hallucinated drug interaction is a patient harm event with FDA 21 CFR Part 11 and EMA GXP requirements, creating explicit traceability obligations. In legal practice, hallucinated case citations constitute professional negligence. In financial services, hallucinated regulatory requirements create direct compliance exposure. In government, the OECD Due Diligence Guidance for Responsible AI, published January 2026, identifies verification of AI outputs as a core due diligence requirement for organizations deploying AI in high-stakes contexts. And in critical infrastructure, K-IROS-3 shows what happens when the gap closes in the wrong direction. V.E.R.A applied to K-IROS-3, the Crumpets analyzer, would classify the flight safety system's claim this vehicle is experiencing failure as an E-type assertion, requiring existence verification before execution authority is granted. The ad verification service would query the telemetry corpus. Does the asserted failure exist as a verified entity, or is this an inference from sensor data? The D service would check whether the detected anomaly is the same entity as a known sensor calibration error under first stage combustion stress. Knuth called his experience a joy. He wrote that he would have to revise his opinions about generative AI. The V.E.R.A reading of that paper is different. Claude found the construction. Claude could not prove it. Knuth proved it. The collaboration produced something neither could achieve alone. That is not a criticism of Claude. It is a description of the correct division of labor between AI reasoning and formal verification. That outcome was the heaven vector. AI discovers, human verifies. The result is trustworthy because both parties contributed what they do best. K-IROS-3 was the Skynet vector. AI decides, no verification occurs. The result is unresolvable. V.E.R.A exists to make the heaven vector architectural rather than accidental. V.E.R.A.S commercial architecture separates what should be public from what delivers commercial value. The verification engine is open source under GPL 3.0. The Crumpets analyzer, the formula parser, the E verification service, the D service, all the NTP logic rules, the API specifications, the Docker Compose lab environment, freely available, community maintained. This is a deliberate architectural choice, a working, auditable, formally grounded verification layer, available to anyone who needs it. That is a public good. The commercial value lives in the domain-specific E-CORPA, a pharmaceutical database listing 500 common drugs with verified interactions, contraindications, and regulatory approval status, traced to primary sources at the FDA, EMA, TGA, and MedSafe-NZ, takes significant expert effort to build and maintain. That effort is the commercial differentiator. The commercial vehicle is Pono Limited. Pono translates from Tereo Maori as truth, integrity, honesty. These are not incidental word choices. They are the project's operating principles, expressed in the language of the country where the work is being done. The Pharma 500 is the first commercial proof of concept. 500 common drugs, verified interactions, full provenance chain to primary regulatory sources. Not the LLM says, this drug interacts with that compound. Instead, MedSafe-NZ confirmed, as of March 2026, that this interaction exists at this severity level, per this evidence base. That is what verified AI output looks like. The implementation is in progress, alongside this architecture. Two components, the Crumpets load analyzer and the formula parser, are already built and tested. The next phase, wire them into fast API endpoints, implement the EA applet, corpus SQL schema, build a Wikidata ETL pipeline, and execute the first end-to-end verified query. The first end-to-end verified query is the inflection point. Everything before it is architecture, everything after it is evidence. Phase F covers the migration plan to get there. Episode 8 in this series documents that roadmap. If you are following the V.E.R.A journey, subscribe. I will share every step, from proof of concept to product. Subscribe to the Hamberger report. New videos every day. That is the Hamberger report for today. If this was useful, subscribe and hit the like button. It helps more professionals find the channel. You will find links to everything we covered in the description below. I am Andreas Hamberger, and I will see you tomorrow.